All right, my little pre-calc babies, we're back for Part B, Chapter 6, Section 1, the Law of Sines. So I think that you would agree with me the Law of Sines is not too bad, right? Not too bad in Part A, some of the problems that we were able to do. And now let's run into a problem. Let's run into a hiccup. So when we have a scenario, and let's start. So I know that if I have a whole lot of clutter here, it's going to be hard. So bear with me. If you have to pause the video, if you are the type that likes to take notes, if you have to pause the video and write everything that I have, then do so. And then unpause it when you're ready to listen to me speak about what's going on your screen, okay? So here's the idea. Assume that you have so for some triangle, right? Some triangle ABC. Let's assume that you're given angle A, right? Notice that on the screen, angle A is fixed. And side B is fixed. Now, to make sense of why this is a little bit hard, I'll come back to that H in just a second. You're also going to be given side A. But stay with me here. Listen. What we're going to do is we're going to see, well, how does the length of side A play a role in this triangle, right? So what I'm going to do is we're going to assume that this guy right here is side A. And if you can spatially imagine here, let's just imagine that you have some type of pivot here, some type of swivel that allows that A to rotate, right? So does that make sense? That this side A can rotate like a clock going around the hours and minute signs, right? So A is hinged and it can rotate. So now, what are we going to do? We're going to look at various sizes of A. All right, so what is this H doing here? So, well, first off, this H is not part of the triangle. Right, this is what we call the altitude, the height, if you will. It's not part of the triangle. It is a property of the information that you're given. Okay. Now that H is going to be meaningful in just a second, and I'll show you what I'm talking about here. So let's play for just a second, right? Let's assume the first case 1. Let's assume that A, right? Because remember, we can play with various sizes of length A, right? So right now, we're going to assume that A is actually less than the height, right? So let's make it small. Okay? So now somebody comes along and says, angle A is equal to this many degrees, side B is equal to this length, and side A is equal to this length. Now, for just a second, imagine if angle A is less than the height. Are you ever going to be able to form a triangle? Right? Like if you can imagine this guy just swiveling around, is it ever going to be able to form a triangle? Is it ever going to be able to touch down here to form a triangle? No, it's not, right? So that's why I said the ambiguous case is a little bit harder, because for a scenario such as case 1, you don't even have a triangle, right? You have no triangle. All right, so I'm going to go ahead and grab this no triangle. I'll put it right here. You can see it a little bit better there. So in this case, you don't notice that when side A is less than the height, the altitude of the triangle, it can't touch. So therefore, it cannot, because you can't change angle A, right? It's not like you can. It's not like you can bring this guy up here to touch it, right? No, angle A is fixed, so you can't change that. All right, so then let's take a so clearly. I'm going to look at case 2, and then I'm going to come back and say, well, wait a minute, how do you even find the length of h? So I'm going to tackle that in just a second. So let's now assume for case 2 that the length of A is actually equal to the height. Right, so let me fix this. So in this case, oh, what's going on? Let's try that again. Get rid of that. Let's assume, and this is probably going to be an epic failure. Nope, look at that. Perfect. So in this case, let's assume that side A is equal to h, is equal to the altitude. What would you have in that case? Well, in that case, you would have a right triangle, right? So in this case, you would have one right triangle. Right, and this is exactly what I'm showing you in this little cutout here. So when A is equal to h, you have one triangle, and that one triangle is indeed a right triangle. All right, well, let's get back to what I was saying. So I'm going to kind of bring this guy down here for just a second. So obviously h is important, right? The height, altitude of this triangle is very important to know if there even is a triangle. So then your question should be, then how do I actually figure out what the value of h is equal to? So we don't have to stay here very long, but the altitude, since that's a perpendicular bisector, the altitude is just going to be equal to, let's think about that. The height is the opposite side of that triangle, right? It's opposite to A. So since you're trying to figure out what h is, the way you want to think about it is, let's use sine of angle, in this case, angle A, is going to be equal to the opposite divided by the hypotenuse. And what I'm going to do right now is I'm going to plug in h for the opposite, and I'm going to plug in b for the hypotenuse. Ready? Let's rewrite that. So sine of A is equal to b, oh, my apologies, opposite over hypotenuse, equal to h over b. Now, that should be easy to you at this stage of the game. So remember, we started this by asking, how do I actually figure out what h is? Right? That was the question mark. So now, all you have to do is take this equation and solve for h. So h is equal, in this case, to sine of angle A multiplied by b. All right, let's take that result. Right up. Will it do it? No, it won't. All right, so let's take that result and write it off to the side. So in this case, h is equal to sine of angle A multiplied by B. All right, let me erase what I have up here. By the way, my picture moved, didn't it? This is see if I can get it back to where it was. Ooh, I don't know. Well, I might have to erase everything here. Ready? I'm learning the technology as I use the technology. Right, young people, I know for you this is easy, but for people like me, this is not as easy. So this was angle A, this was side B, this was H, and I'm making this a dotted line because I just don't want you to think that's actually a side of the triangle. All right, so now let's get back to our result, or our inquiry, if you will. So now that we actually, so are you with me? Or did you take a look at your phone for a second? Did I lose you? Are you back? Do I have your attention again? So we now know how to find H, the altitude of the triangle, the height of the triangle. So in case 1 or case 2, if you know what H is, right, you have to calculate H, and then you know what A is, the length of side A, remember that is given to you. Then you can say right from the beginning, if A is less than H, no solution, no triangle. If A is equal to H, this is one solution, one right triangle. And now let's run into cases 3 and cases 4 where it gets a little bit tougher. So let's look at, so let me go ahead and look at case 3. So for case 3, let's see what we have. So we have length of A is bigger than H, okay? So it is larger than H. But, and for case 3, and it's larger than B. So ready? I'm going to do my best here. I don't have no idea if this is going to work out. So clearly that is larger than A. I'm sorry, that is larger than H, and it's larger than B. Okay. So in this case, what are we going to be able to, what is this going to tell us? So in the scenario where the length of A is larger than the length of H, that means we do have a triangle. Since it's not equal, it's not a right triangle. It's going to be some type of oblique triangle. Now, because we've also said that side A is larger than side B, what are the consequences of this? Well, do you see how if I were to extend, right, if we extend this out a little bit, do you see how you have one large triangle? And that is the case. Case 2, you would have one, but not right triangle. It would be one oblique triangle. So, now what is the hardest question I could possibly throw at you? Well, it is indeed the scenario where case 4, the length of side A is larger than H, so there definitely is a triangle, but it's less than B. So ready? I need to see if I can make this work. So it's got to be larger than H, less than B. I hope that that'll work. All right, are you ready? Here we go. This might be an epic failure. But for case 4, because of those conditions, the length of A is larger than H, but less than B, you actually can get 2 different triangles, right? So here's one triangle. Here's one possible triangle. So what I just drew there, you would agree with me that that is definitely one triangle. But now, if we let this swivel a little bit, ready? Do you see how you can, if I let it swivel all the way to the left, do you see how you can also get a second triangle? Like a big one and a small one, right? A large triangle as well as a tiny triangle. So this indeed is the toughest case, a scenario where if A is larger than H but less than B, you will actually get two triangles, right? Two oblique triangles. And that is exactly what I'm trying to point out here with this little piece. So, okay, I know that was tough. I appreciate your patience through that. But it is worth the investigation to understand why it is that this problem right here is a lot tougher than the problems that we did prior, okay? So, notice the question begins the same. It says solve triangle ABC if A is 43 degrees, little a is 81, and B is 62. Now, I would be highly impressed if you know that this is going to be an ambiguous case for the law of sines just right now. But you don't need to. Just draw a triangle, okay, and start to label. So in this case, A is 43 degrees. Little a is equal to 81, and little b is equal to 62. Now, what you have in this scenario is an angle side-side or side-side angle. You have the ambiguous case for the law of sines. So all that I ask is that you be able to recognize that, hey, wait a minute. This is one of those weird scenarios where I might not even have a triangle, right? You'll have to be able to recognize that from the information given. But once you have recognized it and you heed my advice just to slow down, then the game becomes okay, well, can I actually find angle B? Can I actually find angle C? And finally, can I find little c, right? All right, so let's jump in. So remember, the key to all of this was, can you actually find the altitude of that triangle? Can you find H? All right, can you find H? So let's go ahead and set this up. So H is what we want. All right, well, as soon as you drop that altitude, that perpendicular, it's going to intersect this base at a perpendicular angle. You now have a right triangle. So the way you want to think about this is, let's see here, let me make sure I labeled everything correctly. Yep. So, all right, so the way we want to think about this is what we saw in the previous result is H is going to be equal to B times sine of A. Now, the only difference is I drew the triangle a little bit differently here than I should have. Let me make sure you understand what I'm saying. On my paper, the one I was looking at right now, I drew my triangle like this. So I had A here, and I had B here, and little a here. So that makes more sense when I think of it as h is going to be equal to b times sine of a, right? If you have to rewind the video on how I figured out what h is, feel free to take a second and then you can catch back up to me. It only takes a second for you to do that. So in this case, h is going to be equal to 62 multiplied by sine of angle A, which is 43 degrees. All right? In other words, h is approximately equal to 42.28. All right, so now that I know h, let's compare it to A. Right, so h is 42.28, A is 81. So because A is larger than h, this means that I do have a triangle. Okay? So then, all right, let me go ahead and now that I know that I actually do have a triangle, let me see if I have more than one, right? So h is 42.28. All right, so definitely because A is larger than h, I definitely have one triangle. It's not a right triangle because they're not equal to each other. But now let's compare A to B. Right, so in this case, A is 81 and B is 62. So A is larger than H and A is larger than B. Ready? I'm going to go back to that last page. So if A is larger than H as well as larger than B, then I have case 3. Right? I have one, it's going to be one oblique triangle. All right, now I'm going to go ahead and give myself some space. I'm going to go ahead and clean all this up. All that work just to know if I even have a triangle. But listen, at this stage of the game, you just go back and start using the same methods that we used on the first two problems, because now you at least know you do have a triangle, and it's not more than one triangle. All right, so let's start. Let's assume that you want to, this is actually a good problem to take notes on because now we want to be able to find angle B. Let's pick some, we need to find angle B, angle C, and side C. We're going to pick angle B. Ready? So what should I use? Well, for sure, if I want to find angle B, I'm going to have little b over sine of angle B. And then think about the information that I have, right? I need these, I need to have both angle, I need to have the angle A and little a, or angle C and side C. I need to have both. In this case, I do have angle A and side A. So this is where I want to go with this problem. All right, so let's plug everything in. So this is going to be 62 over sine of angle B, and that's going to be equal to 81 over sine of 43 degrees, okay? So do I have 3 of the 4 parts? I do. We can now cross multiply and divide. So let's go ahead. I'm going to go through this because it's the first time we've actually solved for an angle. So 81 times sine of B is equal to 62 times sine of 43 degrees. All right. Now remember, you want angle B. So let's go ahead and divide both sides by 81. So sine of B is equal to 62 times sine of 43 degrees divided by 81. Now, do me a favor. Why would so if I go ahead and take, let me do it. If I have sine of b, if I go ahead and take 62 times sine of 43 degrees divided by 81, okay, as long as I'm in degree mode on my calculator, it's going to roughly give me 0.5220. And now let me pose a question to you. Ready? Why is it that if a student writes 0.5220 right here, for angle B, why is that wrong? Why is that a mistake? Because that's not angle B. That's sine of angle B. Right? So most common mistake. This is not your answer. So if you want to find an angle, you're going to have to use sine inverse. Right? So just keep that in mind, that if you didn't use sine inverse throughout this process, you did not find angle B. So sine inverse of what? Well, sine inverse of 0.5220. You actually could, your calculator's probably robust enough just to put all of this. 62 sine of 43 degrees over 81. If you put all of that in your calculator. All right, now look, I would say that B is roughly equal to 31 degrees. Okay, I'm rounding. You should try it just to make sure, so you get a feel for it. Roughly 31 degrees. Okay, so the good news is, once I have angle B, I already had angle A, then you and I agree that angle C is going to be easy? Right? So angle C is simply going to be 180 degrees minus 43 minus 31. Right? So angle C in this case is equal to 106 degrees. Okay, so the last bit of information here that we need is for us to actually find little c. All right, so I'm going to go ahead and use A over sine of A. All right, so at this stage, we're actually solving for a length of a side. We're not solving for an angle, so I'm going to go through this quickly. We've already covered this. So little c over sine of 106 degrees is equal to little a over sine of 43 degrees. All right, if you solve for c, you get little c is roughly equal to what? I believe it's somebody, well, I almost said somebody correct me if I'm wrong. I don't know how you would do that, but 114.17. So little c is 114.17, and that's it. You have solved the triangle. Okay? All that work up front was just to even know if you have a triangle. But now that you know you have one, you follow the same steps. All right, so if I'm you, I would pause the video and try this. Right? See if you can find H. See if you can even tell if you have a triangle. All right, so I'm going to assume that you actually listen to me. And I'm going to go ahead and label everything. So in this case, A is 75 degrees. Little a is 51. And we'll go ahead and say this is angle B, this is angle C. So little b is 71. I just want it to look like the ones that I drew out in the previous pages. And I'm noticing that, wait a minute, this is the ambiguous case for law of sines. So I might not even have a triangle here. And if I do, I might have two of them. So I need to slow down. My first job is to actually find h, right? So since sine of 75 degrees is equal to the opposite over the hypotenuse, that means sine of 75 degrees is equal to h over 71. So what is h equal to? H is equal to 71 times sine of 75 degrees. All right. H is roughly equal to, what do we got? I'm getting 68.5. Ready? Let's compare that to A. All right, so in this case, H is larger than A. 68.5 is larger than 51. So what does that mean? If H is larger than A, you don't have a triangle. Right? This is no triangle. No solution. Now, I want to do something because no matter how many times I show students that you should start by trying to find the altitude, we're just creatures of comfort, and we are pattern seeking and habit forming creatures, and it's just, without a doubt, someone is just going to jump in. And so what I'm going to do right now, okay, so the problem's done, okay? What I'm going to do right now is to give you a check so that if you jump in and you don't notice H is larger than A, I'm telling you that eventually you would find out there's no triangle no matter what. If you set up sine of B, right, you jump in and start trying to solve, and you might get 71 sine of 75 degrees over 51. So listen to me. Right now, at some point in this problem, your calculator is going to start screaming at you, error. So if you take sine inverse of 71 times sine of 75 degrees over 51, right? In other words, I'm saying you don't pay any attention to me about trying to find the altitude. You jump in and start using the law of sines. Then at this stage right here, your calculator is going to start telling you error. Right? Because sine inverse, I just did it on my calculator. So 71 times sine of 75 degrees divided by 51 is about 1.34. And what I'm saying is if you put 1.34 inside your sine inverse, you're going to get error. Okay, so this is your calculator's trying to tell you that you don't have a triangle, right? The domain, or we should think about, so remember when you do the inverses, the range of sine is from -1 to 1. So when you take sine inverse, the domain is from -1 to 1. So 1.34 is not in that domain. That's why your calculator is telling you error. Your calculator is telling you error because A is not big enough to touch. It's not big enough to long enough to form a triangle. All right, I'm going to, we've been going at this for a while. The last case is when you have to solve a triangle where I'm going to have to scoot through this quickly. all right? This is going to be one of those cases where you do have two triangles, all right? And what I'm going to do is I'm going to just forget about trying to find the altitude and figure out how do you know that you have two triangles. I'm just telling you right now that this is a scenario where you have two triangles. You have one large one, and you have one small one. Okay? So let me just assume that, so this is angle A. This is 40 degrees. And let's assume that you put this is going to be B sub 1. I'll put A sub 1, B sub 1, C sub 1, little c sub 1, little b sub 1, little a sub 1. So notice how the hardest case is when you have two triangles that you need to solve for. That's a lot of information that you have to be able to give your professor. So let's label this C sub 2. Let's label this A sub 2, B sub 2. All right, now, if you'll just listen to me, what are you going to do? I mean, if I say this is the hardest thing, what do you do? Just give up? Just go to the next one? You know, skip that one, hope it's not on the test, change your major? What's your game plan here? Well, if you have a lot of math in front of you, let's start to embrace challenge, okay? Challenges. You can do this. This is not bad. And if you listen to this little piece of advice I'm going to tell you right now, I can make this a lot easier. So remember it was, and remember angle A, or I'm sorry, side A was allowed to swivel, right? We were allowed to rotate it about that hinge, right? So we can move it around. That's why we were able to form two different triangles, because angle A can swivel around. Now, let's you and I agree on something. Let's you and I agree that no matter how A swivels around, side B is never going to change, right? Right? The length here is going to stay the same no matter what side A does. So what I'm telling you is if B is 62 here, it's going to be 62 here. In fact, angle A doesn't change either. So if angle A is 40 degrees in the big triangle, angle A is 40 degrees in the little triangle. In fact, furthermore, what else doesn't change? What else doesn't change? Well, it is true that side A is allowed to swivel around, but side A doesn't change either, right? It's not like it's while it's rotating, it grows larger or smaller. No, side A also stays the same. So do you see how a lot of this information carries over to both triangles? So what is it that we want? Well, obviously we're going to need, for the first triangle, we need angle C, we need side C, and we need angle B. Now these will be different for both triangles. For triangle 2, we're going to need angle C, side C, and angle B. And like I said, these actually do change for each triangle. So if you allow me, let's assume that you went through the process and let's say you jumped in trying to solve this this triangle. You figured out that it was definitely two triangles, and if you'll just allow me to get you to a result here. So let's assume that you wanted to figure out what angle A is. So you started here. Oh, my apologies. You wanted to figure out what angle B is. So you started here. All right, so you're like, okay, you know what? I'm going to start with the big triangle. So you plug in. So in this case, we have 54 over sine of 40 degrees is equal to 62 over sine of angle B sub 1. All right, now, here's the last trick that I'm going to give you. You go through all that math that I've already shown you, and you figure out that angle B sub 1 is equal to 48 degrees. Okay? So what did you just do? You just figured out that angle B sub 1 is 48 degrees. 48 degrees. Now, are you listening to me? If you have, please come back to me. I'm about to give you the greatest gift that I can give you in a math class. A shortcut. Ready? So, if you agree with me that you went through the work and you now know what angle B is for the large triangle, you watch how quickly you can get angle B from the small triangle. Just take 180 degrees minus whatever you got for angle B of the large triangle. So minus 48 degrees. And I'm telling you what's left, the 132 degrees, is the angle B of the small triangle. Right? That's not bad. Now, so at this stage, do you agree with me? You have two angles. You have angle A and angle B. Then, well, finding angle C is easy. Right? You just 180 degrees minus. So angle C for, let's go ahead and do the large triangle. So angle C is 92 degrees. And angle C of this tiny triangle, this should be a tiny angle, and it is. It's 8 degrees. Now, finally, again, you have a whole lot of information. The only thing left to do is to use the law of sines to figure out side C. And I'm just going to give you those results. You can go through them on your own time. What you should find is that side C for the large triangle is 84, and side C of the small triangle is 11.7. Hats off for your patience, because I know that's not easy. That's a tough lesson. This is a tough thing to teach as well, especially online. But I will see you soon. Take care.